with respect to the origin, I got point A with a position vector of 1, 3, negative 4. And then the point B has a position vector of negative 12, 8, and 4. Point P lies on OA, the Q and R such that PQ is 1/3 of QB and OR is 5 of OQ. So part 1 requires us to show that R is on the line whose vector equation is, so this is R lies on the line. The vector equation is as follow. Okay, so I need to find, what I need to do is if I want to show that R lies on the line, okay, what I need to do is, okay, I know that I need to find R, and R, if I look at the question, right, R is actually listed over here, so that means R comes from Q. Okay, so the thinking process, I need OR, that means I so-called need find Q, and if I want to find Q, Q actually comes from here, PQ and QB comes together. So mainly we think about the fact I need to find R means I need to find Q. I need to find Q means I need QB. And then looking at this, you do suspect maybe there's some ratio theorem involved. There's probably some ratio theorem that's involved. Okay, so let's try to draw out. If we draw out over here, alright, there's a OA, there's a OB. Maybe I put A here and maybe B here. Okay, then I know that point P is on the line OA, so point P could be somewhere here. Maybe I just put point P here. Okay, and Q and R are such that PQ, right, is equals to 1/3 of QB. So if maybe I draw the line PB first, PQ, there's a PQ, this is 1/3 of QB, so PQ is 1/3 of QB, the ratio is like 1:3. OR is 5 times of OQ, OR 2, 3, 4, 5, OR, maybe OR could be somewhere here. Okay, so it may not look very pretty, but the idea is you are not given marks for this diagram. You basically need to see whether you are able to draw OA, as we found, right, your A is equals to 1, 3 of negative 4, and B is equals to negative 12, 8, and 4. Okay, so with that, right, let's look at how we can identify or how we can find our OR. To find our OR, we need OQ. OQ is possible to find what's OQ because if you think about it, if I use ratio theorem, right? Okay, actually OQ can be found. So using ratio theorem, right, OQ, basically you can say to find OQ, I just use, to find OQ, right, I can use OP times 3 unit, OB times 1 unit divided by 4. Okay, so that's a ratio theorem here. Okay, so come to this part. OQ basically is one set of equals to 1 of negative 12, 8, 4 plus 3 set of OP. Alright, and OP, right, the interesting thing is OP here, we have nothing about it, but all we know is that it lies on OA. So we can say, right, this OP, right, can be written as some sort of a scalar multiple of OA. Can I write? Because OP lies on OA. OP, I can write as a scalar multiple of OA. So that's what I do. Okay? And from here, then I go on to write down ratio theorem 4. And simplify my terms. This is what I get. I get negative 3, 2, 1 plus 3, so-called 5 over 4, 1, 3 of negative 4. And what I can do is basically I can just take this whole thing. Alright, I just write it as another scalar. Maybe I just write it as alpha. Okay, it's equals to negative 3, 2, 1 plus alpha 1, 3, negative 4, where alpha is real. Okay, and this one is 3 theta over 4 is real. So that gives us so-called the form or the template of how OQ looks like. Okay, when it gives us how OQ looks like, and this is how OQ looks like, we go back to the question, and the question tells us that OR, since OR is basically our 5 times of OQ, am I right? So OR is 5 times of OQ, then OR, I just take OQ multiplied by 5. Okay, so it's 5 times of OQ. Alright, and if you so-called multiply the direction vector by 5, it doesn't really matter because we don't need to look at how big the direction vector is. Alright, so OR basically can be written in this form: negative 5 times 3, 10, 5. Okay, for the position vector, however, we do need to multiply by 5. For direction vector, no need. Maybe just call it theta. Okay, because the question has already so-called use theta lah, theta is real, where basically my theta is my phi alpha. Because I just here we know because OR is 5 times of OQ, I multiplied by 5, and I just replace the phi alpha with theta. Okay, and with that, OR is okay. So with that, right? Okay, I actually showed that OR lies on this line. So if you look at the format of OR, indeed OR lies on the line whose vector equation is negative 15, 10, 5 plus theta of 1, 3, negative 4, and we are actually done with part 1. So for part 2, okay, the plane contains the line and is parallel to the vector 11. The plane contains the line and is parallel to the vector 11, 7, 8. Okay, plane P contains this line parallel to this vector. The line through A perpendicular to P also meet P at L. So we need to find the position vector of L. So you look at this question, this is basically all we are doing. This is basically finding the foot of the perpendicular from a point A to the plane. And this perpendicular is basically called L. Okay, so what we need to do is we need to know what the plane look like. We need to know what the point look like. Okay, we need to know the plane. How do you know something about the plane? We got to draw it out. Okay, so if you don't draw, you will not be able to see anything. Okay, just follow the question sincerely. The question tells it contains a line. Okay, so it contains a line. Right, this line basically is negative 15, 10, 5 plus theta of 1, 3, negative 4. Theta is real. Okay, this line also contains parallel to another vector. Maybe the other vector is 11, 7, 8. Okay, there's a line passing through A, maybe passing through A, perpendicular to P. Okay, it meets P at the point L. Alright, so what we need to do, we are supposed the business here of whole part 2 is to find what is this. Okay, so to find what is this, right, you think about it. To find this, you really need equation of the plane. Okay, you need the equation of the plane, and probably the most useful form to find the scalar product form, and not just any form. Alright, so you actually need the equation of the plane in a scalar product form. Just looking at this, you can actually find the equation of the plane in parametric form. Okay, if you think about the equation of the plane in parametric form, it's quite fast. You can actually see right away. Okay, it's just R equals to negative 10, 15, 5 plus theta of 1, 3, negative 4 plus alpha of 11, 7, 8, where theta and alpha are real. Okay, this actually, because you got it right, we actually have found already have two parallel vectors. Alright, you have position vector. Okay, so this is basically this is like the A, this is the M1, this is the M2. Okay, for the equation of the plane. Then how do we come up the scalar product form? Scalar product form is very simple. We just take these two, okay, you cross product and you will get your normal. So the normal vector of the plane, you can take 1, 3, negative 4, cross product with 11, 7, 8. I'll leave you to do this. All goes well. You should obtain the answer to be 26, 2 of negative 2, negative 1. Also, since we are taking a normal vector, we don't need the whole vector itself. We can just find a reduced representation, or just factorize out, and we can basically take n. We take our n to be 2, negative 2, negative 1. We don't have to just take a small scalar multiple. Alright, as the normal vector, of the plane. Alright, now we just go back to our question, right, which is r dot n. We are finding the equation of the plane in scalar product form. R dot n, n is 2, negative 1. What is A? A is the one that we have, negative 2, 10, 5, dot product with n. Alright, solve this. And the equation of the plane should turn out nicely to get r dot 2 negative 1 to be equal to negative 55. Okay, with this, right, well, once we have the equation of the plane, if we go back to the question, this just tells us the equation of the plane, r negative 2 negative 1 equals negative. With this, right, we are more secure, we are more secure. We are able to use this to help us to find L. Okay, how? Okay, we know AL. Okay, let's look at maybe the AL. Okay, so AL, right, if we look at OL, we find the fourth perpendicular from the point. Let's look at the equation of this line. Okay, if you look at the equation of this line, okay, look at the equation of this line, okay, and we look at the equation, this equation of line, if you look at the equation of this line, it actually, in the equation of AL, right, okay, it looks something like, because OA is the point 1, 3, negative 4. The equation of AL is 1, 3, negative 4 plus so-called alpha of wait, let me see, plus alpha of where's 2, negative 1, where alpha is real. Okay, understand how I get this? Because I use the normal vector of the plane, which is over here. Okay, so AL, basically because it passes through the point A and uses the normal vector of the plane as a direction vector, I can write the equation of AL in this format. The nice thing is this, you know that OL lies on the line also, right? Because OL lies on the line. OL can be written as 1 plus 2 alpha, 3 minus 2 alpha, negative 4 minus alpha, right, for some alpha, which is real. Okay, and what we do is we just solve these two simultaneously. We actually look at these two, equation 1, equation 2, and we solve these two simultaneously. Alright, looking at the two of them carefully. Okay, so what we do is just solve the two simultaneously. Equation of the line AL, alright, first one, basically solving the equation of the line and the plane simultaneously. And what we do is equation of the line, alright, and equation of the plane. What I just do is I just take all the x, y, z and I put it here. Okay, so dot product with 2, negative 1 to get negative 55. All goes well, my answer should come out to be, I should have something like 2 sets of 1 plus 2 lambda minus 4 minus lambda equals to negative 55. Continue to solve this, my lambda should be 55 over 9. Okay, hence, okay, I know it's a long question, so bear with me. So hence, OL, after you found the lambda to be negative 59, just substitute back into your OL. Okay, back into this now. Equals to negative 101 over 9, 137 over 9, 19 over 9. That is the OL. Okay. Last one. Okay, I need to find the position vector of the reflection of the point A about the plane P. Again, you need to find the position vector of the point A about the plane P. So if you just observe, we were at this portion just now, right? It's like about the plane P, right? This is the point A, right? Then below there's a A prime. Let's call it A prime. This is like the reflection about the line plane P. If you look at this plane from a cross-section point of view, it's like you have the plane here. Alright, I have the point A. The point A was 1, 3, negative 4. Alright, the fourth perpendicular we found just now, remember? It was actually negative 101 over 9, 137 over 9, as well as 19 over 9. And we are finding the reflected point about the plane. Okay, so it's very easy. So once we have told you that, remember, you can always use ratio theorem. All of them are reflected back to O, OA, OA prime, and okay, I mean, with that, using ratio theorem, you know that the ratio here is 1:1. Okay, 1:1. OA plus OA prime over 2 is the midpoint. Okay, just solve this slowly. You should get your OA prime to be equals to negative 211 over 9, 247 over 9, as well as 74 over 9. Alright, that's for OA prime.